Hello and welcome to the second vectors video. Now in the last vectors video we started looking at vector journeys where we were combining different vectors together and adding them or subtracting them. Now we're going to be doing that again, but first of all I'm going to introduce a new bit of notation. So here, if I had an O and then an A with an arrow over it, that means I'm going from O to A. Obviously order is very important because vectors have a magnitude and a direction. So here my vector A here is O to A. So the vector O to A is represented by A. Here I've got B, which is going in a direction from O to B. O to B is represented by this vector B. So here I've got three different points on my 2D plane, on my space here, on my sheet of paper. Now, can we show that O to P is 3A plus B, where A is here, the vector 1, 1, and B is the vector 1, 0? Yes. Here, O to P, I've got 1, 2, 3 A's, and then add B gets me to P. Now, I didn't have to do it in that order. I could have done B and then 3 A's. I could have done A and then a B and then 2 A's, or 2 A's and a B and then an A. I could have done 4 A's and then a B and then a negative A. That would simplify down to 3A plus B. Doesn't matter how I actually represent that picture, the simplest it would look like is 3A plus B. Now, the vector O to Q, so O to Q, is represented by negative 2A, take away 3B. So remember, negatives means in the opposite direction. Let's do this in a different color. So let's say here, negative 2A is going to be in that direction. Went a little bit too far there. And then negative 3B means I'm going to be going in the opposite direction. I'm going to go left 3 times. Here, that is negative 3B. Apologies if you hear my cat in the background. He's not happy that I'm ignoring him. Now, here, you don't really need to know it for GCSE, but just as a fun little extra fact, any vectors, any two vectors that are not parallel, you can represent a journey between any 2 points on a 2D plane as a combination of them. So as long as these are not parallel, any two vectors, you can get from any point to any point in a combination of them. Now, in GCSE, we don't usually have a big open 2D space. They like to think much more small than that, and we usually stay within a specific shape. So here I've got a parallelogram, R, Q, P, and O. I've got the vector R, which goes from O to R. And I've got the vector P, which goes from O to P. I've got M, which is a midpoint of RQ, and I've got N, which is a midpoint of PQ. So, in the middle. Let's use R and P to represent different vectors. So, R to Q, here, well, it's a parallelogram, so that is going to be parallel and the same length, the same magnitude as this, so that has to also be P. Similarly, P to Q has to be exactly the same as this. That's going to have to be R. Then, R to M. Well, R to M, here, while M is in the middle, it's going to be half of this previous distance here of R to Q. Here's a new fact. We can have half vectors. That's half P right there. Similarly, P to N would be half R. N to Q would also be half R. M to Q would also be half P. Now, this one in red, a little bit more tricky. O to Q. Now this is a combination of more than one vector. So from O to Q, I've got to go from O to R, and then I've got to go from R to Q. So there's a combination there of the two of them. So that would be R plus P. I didn't have to do it that way. I could have gone from O to P and then P to Q. I could have had P plus R, which means exactly the same thing as we saw in the previous video. So P to R, P to R, P to R. Well, let's go P to O, and then O to R. So here, P to O is negative P, because I'm going in the opposite direction. And then O to R, that is the normal, regular, positive R. So it'd be negative P plus R. Again, I could have gone the other way. I could have gone P to Q, and then Q to R. So I could have gone R, take away P, means the exact same thing. Negative P plus R is the same as R, take away P. All right, let's get even trickier. O to M. So O to M is going to be me doing O to R. So it's from here to here, and then going from R to M. So that's going to be R plus half P. O to N is going to be going from O to P, and then P to N. So that is P plus half R. M to N. Ooh, well, M to N is me going to be going from M to Q, and then Q to N. So M to Q is half P, and Q to N is going to be negative a half R. So I'm going in that opposite direction. P to M, well, let's say that's going from P to Q, and then Q to M. So that is going to be R, and then negative a half P. So I'm going backwards, opposite direction from P. I'm only going half the distance of P, so R minus a half P. R to N, well, that's going to go from R to Q, and then Q to N. So that is P, and then negative a half R. Again, with a lot of these, there's more than one way of doing the journey, but it would still simplify down to exactly the same thing. Okay, so first, we're not quite at GCSE standard yet. We're getting there. Here, I've got a triangle. So O to P is A with the arrow. O to Q is B with the arrow. What is my vector Q to O going to be? Well, that is the opposite direction to B, so that's going to be negative B. Q to P, well, that's going to be a combination of them. That's going to be here, going from Q to O, and then O to P. Now, there is this line drawn here, right? And you look at this and you think, well, I just want to go along this line. But that's not one of my vectors. I have to use this as a combination of A and B. So I have to do it as going from Q to O, and then from O to P. So that is negative B plus A. Negative B plus A. P to Q, again, I can only use my vectors. That's going to be P to O, and then O to Q. And then that's going to be negative A, and then positive B, because that's in the same direction. One thing to note, here, Q to P, P to Q, these are opposite directions of each other. Here, these are the negative versions of them. Negative of this is this, negative of this is this. And again, remember, it doesn't matter the order that I draw these in. Okay? We could go off-piste. Here I could have pretended it was a parallelogram where that is also A and that is also B. So this one I could have gone A and then minus B. This one here I could have done B minus A. Okay, as long as we're working in terms of A and B, we're going to be correct. And again, the order with the adding and subtracting, not important. Okay, we're still not quite, I'm going to be honest, we're still not quite at GCSE level. Still getting there. Here, I've got a new triangle. I've got my vector X, here my vector Y, and I've got M here as the midpoint of BC. So, what is my vector BA? Well, BA is in the opposite direction of X. That's going to be negative X. BC, here, again, I have this lovely line drawn. Can't go along that line, it's not a vector. I have to go B to A and then A to C. So there I have to go negative x and then plus y. B to m. Well, B to m is the midpoint. M is in the middle. It's in the middle of this line. B to m is half of the vector B to C. That is half the journey of that. So that is a half of negative x plus y, what I just worked out previously. Well, that means that it is negative a half x plus a half y. A to m. So I'm going from A to m. So here I need to go from A to B, and then I need to go from B to m. Now it's very useful, I've just worked out what B to m is. So A to B is x. B to m, I've worked out here, is negative a half x plus a half y. So if I have a whole x and I'm taking away a half x, well, we can think of that as 2 over 2x, take away a half x, I'll be just left with a positive half x plus a half y. Now, still not quite to GCSE level. This question, just a little bit more tricky. I've got here my vectors A between O and P, my vectors B between O and Q, and T is the point on PQ such that PT to TQ is in the ratio of 3 to 1. So this is 3 parts, and this is 1 part. So, P to Q, well, again, can't go along this line, have to use the vectors that I have. So P to Q is going to be going from P to O, and then from O to Q. So that is negative x plus b. P to T. Now P to T is a fraction of the journey P to Q. And the fraction that is 3 out of 4 parts in total. That is 3/4 of a way along from P to Q. Well, I know what P to Q is. So it is 3/4 of negative a plus b. That is negative 3/4 of a plus 3/4 of b. Now, last part, what is O to T? Well, O to T, I need to go from O to P, and then I need to go from P to T. Now, I've just worked out what P to T is. O to P is A, P to T is negative 3/4 of A plus 3/4 of B. So let's simplify that, and we've got a whole A, take away 3/4 of A. Well, that is 4/4 of A, take away 3/4 of A. I've just got 1/4 of A left, plus 3/4 of B. Now, we've pretty much been doing GCSE questions. Now we're going to have a look at actually what the GCSE questions look like. Now, the only difference here is I'm going to stop breaking things down into steps for you. So here in the triangle AOB, we've got A to M from M to P in the ratio of 2 to 1. If O to A is A and O to B is B, find O to M in terms of A and B. So we've kind of done this already, but we've done it broken down in steps. Here it's not breaking down the steps for you. You need to know how to do this on your own. So if I'm going from O to M, I'm going to do this as O to A, and then I'm going to add A to M. So I'm going from O to A and then A to M. That's how I go from O to M. Now, O to A is easy. A to M is a fraction of A to B. Now that fraction is 2 out of 3. That is 2/3 of the journey from A to B. Now, I know all these are. Here, O to A is A, lowercase a. plus 2/3 of a to b. A to b is easy. A to b is negative a plus b. So let's expand that out. I've got a, take away 2/3 of a, plus 2/3 of b. If I have a, and I take away 2/3 of a, well, that's 3/3 of a, take away 2/3 of a, I've got 1/3 a, plus 2/3 b. That's a GCSE question. It's all the stuff that we've done before. You just need to know what all of those parts are going to look like yourself. Now, very similar question, slightly different, where here I've been given that this vector here is 6a, and this vector here is 6c, so I've got multiples of them, but it's exactly the same idea. I've got a parallelogram, OABC, and a to p to c is in the ratio of 2 to 1. Find the vector O to P. Well, the vector O to P, I'm going to go from O to A. And then from there, I'm going to go from A to P. Again, I know what O to A is. That one's easy. A to P is a bit of bother. It is a fraction of the journey from A to C. What fraction is it? That is 2/3. That is 2/3 of the journey from A to C. So O to A is 6a, and I'm going to have to do 2/3 of A to C. A to C is negative 6a plus 6c. So expanding that out, that is 6a. 2/3 of 6 is 4, so that's negative 4a plus 6c. That is just going to be 2a plus 6c. Find the vector P to B. So, you know what? I've already used A to C, going in that direction. So let's do P to C. Let's keep the same direction. So I'm going to say P to B is, you see that? Yep. Is P to C, and then C to B. Again, more than one way of doing it, but the answers will simplify down to the same thing anyway. So P to C is a fraction of this whole vector. That is 1/3. That is 1/3 of the vector A to C plus C to B. So A to C, we've already talked about A to C. A to C is negative 6a plus 6c, and C to B is easy. It's a parallelogram. That's going to be 6a. So 1/3 of 6 is 2, so that is negative 2a plus 1/3. I've just noticed a mistake I made all the way back here. 2/3 times 6, I forgot to change that to 4. Ooh. Bonus points for whoever figured that out before. Let's go back to this question. 1/3 multiplied by negative 6a is negative 2a. 1/3 times by 6c is 2c plus 6a. That is going to be 2c plus 4a. So again, here, the GCSE questions, the only difference is it is not broken down for you as much. Here, ABCO is a parallelogram, A to P, P to C is in the ratio of 2 to 3. Find the vector P to B in terms of A and C. Well, again, we've done a similar question to this already. We just need to follow the steps. It's not broken down for us. But we know if we're doing P to B, we have to go from P to C and then C to B. So P to C is a fraction of this vector A to C. What fraction is that? That is 3 out of 5. So that is 3/5 of the vector A to C plus the vector C to B is easy. So we have got 3/5 of A to C is negative A plus C added to CB, which is just A. So that is negative 3/5 of A plus 3/5 of C plus A. So here, negative 3/5 added to a whole of A, so that is 5/5. That is going to give me 2/5 of A plus 3/5 of C. Brilliant. Now, here we go. Last one. Tricky GCSE style question. Here, I've got a triangle again. I've got vector Q and I've got vector P. Q to A and A to P is in the ratio of 3 to 1. Now, O to A is equal to something times by Q plus 3P. Find the value of K. Well, all this is telling me is this is what my answer is going to look like. So let's get an answer. What is the vector O to A? If I'm doing O to A, you know what, if actually changing colour, let's change the colour. If I'm doing the vector O to A, I'm going to go O to Q and then Q to A. O to Q is easy, I can see what that is. Q to A is a fraction of the vector Q to P. What fraction is that? Well, that's 3 out of 4. That is 3 out of 4 of the vector Q to P. So here, O to Q is Q plus 3/4 times by the vector Q to P. So Q to P is negative Q plus P. So that is Q, take away 3/4 of Q plus 3/4 of P. So Q, take away 3/4 of Q is going to be 1/4 of Q plus 3/4 of P. Now we're told that we want that to look like this. We want it to be something times by Q plus 3P. Well, what am I multiplying this by to get this? Well, that's just 1/4. Done. And you can put a little proof box at the end. So, if you're stuck, all you need to do is break down the steps of the journey. You're going to be given a big journey to do, break it down into the smallest steps you can. Some of those steps are going to be a fraction of a journey, but it'll be a fraction of an easy journey.